some vocab. So our words are function. A function is a relation in which each element of the domain is paired with exactly one element of the range. So for domain and range, you guys could use like the letter D and R so you don't have as much to write. I know it's a little bit of writing today, I'm sorry. Function notation is just f of x. So again, you don't have to write what's in the parentheses. That's just how you say it. It's read as f of x or a function of x. The vertical line test is a test we use to determine if a function is if a graph is a function. If functions are one-to-one, each element of the domain pairs to exactly one element of the range, and it will pass the horizontal line test. And then onto says each element of the range corresponds to an element of the domain. And then if it's both, you can, for one-to-one and onto, that's just both. So one-to-one and onto is both, the two definitions above. And then the last one, guys, again, it's just both. So I have both the definitions typed out, right? Both of them again, you can just put an error. Because one-to-one and onto means it's both of those definitions above. It's both one-to-one and onto, which means it's both the definitions. Sorry, do you still need that? Anybody else still need it? This? Oh, if and only if. No, I didn't have like an issue where I can't spell too. Sorry, yeah. F of A equals F of B if and only if A and B are the same, and it passes the horizontal line test. So we're going to look at graphs today where we talk about the vertical and the horizontal line test to understand that definition. So in those first three examples, we have mapping diagrams. So again, this is a mapping diagram. We learned how to map yesterday. In order to determine whether a mapping diagram is a function or not, we look at the domain and we see how many values are coming from the domain. So in this case, they each have one arrow. Therefore, those are functions. So they each have one arrow, therefore they are functions. And then we want to determine whether that function is one-to-one, onto, or both. So in this case, for every x, there is only one y, and for every y, there is only one x. That fails. So because 6 has two arrows, it is not one-to-one. Since 6 has two arrows, it is not one-to-one. Since every value in the range has an arrow, it's onto. Number 9, that is not a function. And if it's not a function, we don't identify it as one-to-one or onto. It has to be a function to be identified as one-to-one or onto. Since it's not a function because x equals 0 goes to y equals -3 and y equals 7. So in case you're wondering why it's not a function, that is the y. Same with number 10. That is not a function because -3 maps to 4 and -3 maps to 5. Okay, 11. 11 is a function because it would pass the vertical line test. If I drew vertical lines at any given time, it only hits the graph once. So that makes it a function. To be one-to-one, it has to pass the horizontal line test, which it does not, because if I draw a horizontal line, it hits at 3 points there, 3 points here. So it can pass the horizontal line test sometimes, but fails sometimes. The minute it fails, it's not one-to-one. However, it is onto. And then 12 fails the vertical line test multiple times, therefore not a function. Okay? And then in the next example, what we want to do is graph that. So in order to graph it, we're going to create a table because we don't really know how to graph without a table yet. It says determine the domain and range. The domain and range of all lines is always all reals. The domain and range of a line is always all reals. So since this is the equation of a line, the domain and range is all reals. And then what we're going to do is just plug in some values of x to graph the line. So I picked even numbers because we were multiplying by a half. You could have done ones and negative ones too. It just is going to give you fractions. So to get the values in the table, what we're going to do is plug -2 into that function. So you get 1/2 times -2 minus 3. 1/2 times 0 minus 3. 1/2 times 2 minus 3. And 1/2 times 4 minus 3. Whatever that equals are the points you're going to plot. So you get -1 minus 3, which is -4. 0 minus 3, which is -3. 1 minus 3, so -2. And 2 minus 3, so 1. So we're going to plot the point -2, -4, 0, -3, 1, -2. Just kidding, sorry. 2, -2, and 4, -1. Connect your lines, and there's our graph. Is this a function? Does it pass the vertical line test? Yes. So it is a function. Does it pass the horizontal line test? Yeah. Does every y value have an x value? So it is 1-to-1 and onto, therefore it's both. So it's a function and 1-to-1 and onto. It's a function and 1-to-1 and onto, so we call it both. Is this discrete or continuous? Continuous, perfect. It is a line, so it is continuous. That problem right there pretty much summarizes all of the key ideas for section 1 in this chapter. It has you finding values of a function, identifying domain and range, identifying a function, and being able to describe the function as 1-to-1 or onto, and then is it continuous or discrete. The last little part is being able to plug in values using function notation. Function notation is no different than me asking you to say find x equals -3, or x equals 0, or x equals 5. But now what we're doing is changing the notation. So in 14, it's f of -3 equals 3, replace the x with -3 minus 5, and then simplify. So what that means is that when x is -3, the function is -14. if you were doing this on a graph, that's the point you would plot. So it'd be like -3, -14. That's the big connection. Okay? F of 0 would be 3 times 0 minus 5. So -5. And f of 5 is 3 times 5 minus 5. So 15 minus 5, which is 10. So in 15, same idea. We're going to find f of -3, f of 0, and f of 5. So in that problem, everywhere you have an A, you're going to replace it with that number. So the only part of the problem that's changing is what you're plugging in. So you could use a calculator if you need to. But in number 3, if you plug in that -3, you get -9 over 4 minus 1. So -9 minus 1 would give -13 over 4. Plugging in 0, that part of the problem cancels. So we get -1. And plugging in 5, you get 15 over 4 minus 1, which is like 4 over 4. So you get 11 over 4. And again, if you were doing it on the calculator, you just have to hit math enter to get it back to a fraction. Okay, number 16, same idea. Let's plug in -3 for y. So negative times a negative is a positive. So 3/5 plus 3/5 is 6/5. Plug in 0. Well, anything times 0 is 0. So we get 3/5. And plug in 5. And 5 times -1/5, those are multiplicative inverses. So you get -1 plus 3/5, so -2/5. In 17, be careful when you plug in that negative. The negatives don't cancel because the order of operations says we have to square that 3 first. So you get -9 plus 1, which is -8. And then -25 plus 1 or negative 24. So just to kind of get into good practice, 14 and 15 are linear, 16 is linear, 17 is what we call a quadratic. So we're going to start talking about types of functions. So that's a quadratic. And then in 18 and 19, 18 is what we call an absolute value. And then 19 is rational. So f of negative 3 is absolute value of 3 times negative 3. Remember, absolute values are like grouping parentheses, so you have to multiply inside first. So you get the absolute value of negative 9, which is 9. F of 0 is 0. And f of 5 is 15. Remember, 19 is what we call a rational. Might be bonus on our next quiz, knowing what they are. And then f of negative 3 is 9 over 1 minus a minus 3, so it turns to a positive. So you get 9/4. 9 over 1 minus 0 is like 9 over 1, which is 9. And 5, 1 minus 5, so you get 9 over negative 4. So your homework is that next page. It's 11 to 13 and then 21 to 32. 21 to 32 are just like these notes. I do.